So now in the next part of the discussion, we'll try to define the Helmholtz free energy F. Okay. So we have defined F as U minus Ts, where U is the internal energy of the system, and you can say that internal energy is the energy required to create the system. And what is Ts? Ts is the bound or latent energy which is unavailable for useful work. That is, the Ts amount of energy which a system has, we cannot convert this amount of energy to useful work. Okay. So the Helmholtz free energy F equals to U minus Ts. It means that if we subtract this unavailable energy from the internal energy, we get the rest of the energy is called the Helmholtz free energy. Okay, so from the internal energy we subtract the bound energy, we get the free energy. Okay, and if from the internal energy we subtract the energy which is unavailable for work, we get the available energy for useful work. Okay, so F equals to U minus Ts means we are eliminating the bound energy which is unavailable for work from the total internal energy of a system. So what do we get? We get the rest of the energy which is available for work, available for useful work, and we call it free energy because we have get rid of the bound energy from the total energy U. Okay, that's why the Helmholtz free energy is energy is called the free energy. This thermodynamic potential is called the free energy because this is the free energy which is available for work. Okay, and it does not contain this Ts term which is the bound energy unavailable for work. So how do we define it? So in thermodynamics, the Helmholtz free energy is a thermodynamic potential. So we have already said that why it is a called thermodynamic potential, because just like any mechanical system which tends to have minimum potential energy, any thermodynamic system at constant temperature and constant volume will also try to have the minimum, will always try to be in the state of minimum Helmholtz free energy. That's why it is called a thermodynamic potential. Okay, so in thermodynamics, the Helmholtz free energy is a thermodynamic potential that measures the useful work obtainable from a closed thermodynamic system. Closed means there will be exchange of heat, there can be exchange of energy, but there cannot be any exchange of mass. Okay, so closed thermodynamic system at constant temperature and constant volume. That is the system, whatever process the system, thermodynamic system undergoes, it has to be isothermal and isochoric. So this is the definition of the Helmholtz free energy. So in thermodynamics, the Helmholtz free energy is a thermodynamic potential that measures the useful work obtainable from a closed system. Okay, so at F equals to U minus Ts, it gives a measure of the available energy for useful work. Okay, obtainable from a closed thermodynamic system. Closed means there cannot be any exchange of mass, but can be exchange of heat at constant temperature, and the thermodynamic system has to be constant temperature and constant volume. Okay, we have already said that we started with the process to be constant isothermal, and then we made delta W equals to 0, that there has to be that is the volume was constant, that is the process has to be isothermal and isochoric. Now the Helmholtz free energy is an extensive property of the system. That is the Helmholtz free energy depends on the mass or the number of particles present in the system. Okay, and since F equals to U minus 2s, in this way we define Helmholtz free energy, and U, Ts, as you know, these all are state function, then hence the Helmholtz free energy is also a state function, and thus the total differential delta F is an exact differential, because we know if we take the total differential of any state function, it will be exact differential, thus delta F is also an exact differential.